Hey everyone, and welcome. Today, we're going to unpack one of the most incredible stories happening in technology right now. We're talking about the evolution of artificial intelligence, how it went from being a simple pattern recognizer to a genuinely sophisticated creative partner.
Really think about that for a second. What if I told you that we've blown past the days when AI was just about recognizing pictures of cats? We are now, right now, in an era where these systems can compose original music, they can design new, life-saving proteins, and they can solve problems that have had humanity stumped for decades. So the big question is, how on earth did we make that jump?
The difference is just staggering when you lay it out like this. On one side, you have the old AI. It was all about classifying data, right? Following patterns that already existed. But on the other side, the new AI is about generation. It's about creation. And it's about solving problems that don't have a guidebook. It's a complete shift from just analysis to actual synthesis.
To really get it, we've got to rewind the clock a bit. Let's go back to where it all started, what we can call the age of AI 1.0.
For decades, the main job of a neural network was basically to be a superpowered sorting machine. They were inspired by the human brain, sure, but they were built to do one thing really well: find patterns and classify information. Their whole purpose was just to put things in the right boxes.
And this journey started way back in 1957. Over the years, these networks just got more and more complex, and they learned to see things in layers. So think about recognizing a face. First, the AI learns to see simple stuff, like edges. Then it learns to see shapes, like eyes and noses. And then finally, it puts all those pieces together to identify a person. That's what we mean by hierarchical pattern recognition. But, and this is the crucial part, there was a massive limitation. These systems could tell you that something was a cat with unbelievable accuracy, but they couldn't tell you why. They were just finding correlations in the data. They didn't have any deeper contextual understanding. So, yeah, they were powerful, but you couldn't really call them intelligent. So what changed? How did AI make this incredible leap from just recognizing things to actually understanding them? Well, it all came down to a single, brilliant, revolutionary breakthrough in its architecture that taught these machines to see the whole picture.
And that breakthrough has a name: the transformer. And look, this wasn't just another small improvement. It was a complete and total reimagining of how a neural network could process information.
The secret sauce here is something called self-attention. Now, older models, they read a sentence one word at a time, which meant they'd often lose the plot by the end of a long sentence. But with self-attention, the model looks at every single word at once. So in a sentence like, "The robot picked up the ball because it was heavy," self-attention lets the AI instantly know that it refers to the ball and not the robot. It does that by weighing all the relationships at the same time. And that's the magic.
This analogy just illustrates the difference perfectly. The old models were like trying to read a whole book through a tiny pinhole, focusing on just one word at a time. By the time you got to the end of a long sentence, you've totally forgotten how it started. Transformers, on the other hand, see the entire page at once, grasping the full context, the structure, and the style, all in an instant.
And this newfound ability to see the whole picture, well, it unlocked a capability that, until then, was basically science fiction. Genuine creation. Suddenly, the entire goal of AI just shifted. We stopped just asking our models, "Hey, what is this thing you're looking at?" And we started asking, "Okay, based on everything you know, what new thing could you create?"
And the results? They have been absolutely spectacular. Models built on this architecture can now write compelling stories, they can compose music in pretty much any style you want, generate breathtaking art, and even write complex software. They are no longer just analyzing our world. They are actively adding to it.
Here's a great way to think about it. AI 1.0 was like a musician who could listen to any song and perfectly tell you its genre and its key, an expert critic. But with this generative leap, that musician can now pick up an instrument and improvise an entirely original, complex jazz solo that has never been heard before. But creating art and writing text, turns out, that was just the warm-up act. The truly profound leap was when this generative power was turned towards the grand challenges of science. This is when we entered the era of solving the unsolvable. And the prime example here is AlphaFold, which took on one of the most notoriously difficult problems in all of biology, predicting how proteins fold into their unique 3D shapes.
This library analogy just explains it perfectly. So before, you had scientists who were like librarians trying to translate this massive library written in a forgotten language, literally one painful page at a time. AlphaFold didn't just translate the entire library at once. It learned the language so well that it could start writing new books, designing brand new proteins to create medicines and materials we've only dreamed of.
And that brings us right to the cutting edge, agentic AI. This is a huge step beyond just generating a response. We're talking about systems that can reason, create a multi-step plan, use tools like a web browser or a code interpreter, and then actually act on that plan to achieve a goal.
And this is not theoretical stuff. The U.S. Department of Energy is building labs where an AI comes up with a hypothesis and then designs its own experiments to test it out. We've already had a deep blue moment for science, where an AI designed a more efficient microchip layout that had stumped human experts for years.
Okay, so here's the crucial point. This immense, world-changing power is no longer going to be confined to massive data centers. It's moving directly into our hands.
The new chips in our phones and laptops can now perform over 80 trillion operations per second. That's TOPS. It's a measure of raw processing power. And it's the hardware that's making it possible for these powerful reasoning models to run locally, right there on your device, without even needing the cloud.
And this is all leading to a concept that researchers are calling infinite memory. Just imagine a device that is a true cognitive partner, one that remembers every single document you've ever read, every conversation you've ever had, and can reason over all of it to help you work, create, and remember.
But listen, this doesn't mean a future without us. Not at all. The real power, the real breakthroughs will be unlocked when we work together. The AI provides this incredible scale, speed, and these novel ideas, while we humans provide the goals, the ethical oversight, the judgment, and that uniquely human spark of curiosity.
We are standing right at the dawn of a new partnership between human and machine intelligence. The question is no longer about what the machine can do for us. The real question is, what will we choose to create with it?